Good morning, everyone. Welcome to the AVI Networks webinar. My name is Ashish Shah, and I'll be your host today. Thank you for joining us. In the next 30 minutes, we're going to talk about AVI Networks' next generation application delivery solution. And then within the first 5 or 10 minutes of presentations, we'll go into a live demo, and we'll also take your questions. Let's go ahead and get started. We'll start with who AVI Networks is. So AVI Networks' mission is to redefine ADC or load balancing space with a more flexible, agile, and a software-defined approach to application services for any environment. A little bit about the company itself. We've been around for over 3 years now, and we're led by our leadership team comes from F5, Cisco, NetApp, and Citrix, among others. And we are backed by some of the top-tier investors, including Lightspeed, Greylock, and Menlo Ventures. What's the main product of AVI? AVI's built the next-generation full-feature ADC solution. So you have your software-based load balancing, application security, including SSL offload, and application acceleration, what you expect from a load balancer or an ADC solution. However, we have built that with the principles of elasticity, visibility, and automation, as we see that in the demo. And the AVI is a software solution that can be deployed on any commodity x86 server, either in a VMware, OpenStack, bare metal, or even a public cloud environment. We have multiple Fortune 500 production customers around the world, including top 2 of the 5 tech companies in the world, 2 of the top 5 cable companies, as well as multiple global financial services and banks. So before we go into the product, let's talk about what triggered us to build our solution. So as we talk to customers, as the customers are building the next generation of data center environments, what they're looking for is a cloud-like scale and flexibility for their business-critical applications. There is a transition happening in the mindset where instead of looking at load balancers or any other layer 4 to layer 7 services as a piece of infrastructure or a network to something that's close to an application. There's a more of an application-centric mindset. And where this is coming from is that these application developers deploy their apps in AWS, for example. They don't wait for days or weeks to deploy a load balancer. Just like they deploy applications in seconds, they can deploy Amazon ELB or any other elastic load balancing solution very, very quickly. And if you look at the web scale companies such as Google's or Facebook's or Amazon's or Microsoft's, they have built their web scale infrastructure on some of these principles, such as deploy on a commodity x86 hardware. Do not deploy appliances which are proprietary or built on proprietary hardware. Software first or software defined environment where you want a programmatic interface to your application-like infrastructure. And what that allows you to do is have a built-in automation and a self-service capability, where, as I said earlier, your app developers can go ahead and fire up a load balancer in 30 seconds or less and not wait for a ticket to be created and your IT team to respond to that ticket in weeks or months. Another key component of these next generation data centers is instrumentation and data collection and analytics. They want visibility into what's happening both in their applications as well as their infrastructure, so they can make quick changes to respond to changing business requirements, changing application requirements, or changing demand. And finally, the next gen of data centers require deployment models that span across on-premises private cloud, public cloud, and even your traditional data centers. So integration with multiple cloud environments is a key. So if you think about it, if these are the principles that you want to build your next generation of applications and infrastructure on, what is holding back from the load balancers or traditional layer 4 to layer 7 appliances point of view? Today, you deploy a box, you deploy a device for a fixed capacity. And if you want more, well, you order, you provision, and then you finally connect in the network, and then you have additional capacity. It takes weeks or months to provision new applications, to add capacity, and so on. There is no automation in the infrastructure that's built in. And this box-like architecture have no visibility into what's going on. It is a black box, literally. And then the fact that it's built on a proprietary hardware, it's quite expensive. And this has a direct impact on your business environment, where you cannot have continuous delivery. If your application developer is developing your applications in quickly with the CI/CD process, and if they have to wait for weeks or months just to be able to test that in a real life environment, you have a problem. You cannot, as we discussed earlier, you cannot empower a self-service solution because you have to create tickets for every change that you make. The other impact that you have is that you're tied to your hardware network and hardware infrastructure. You do not get AWS like elasticity, where if you want more capacity, it just automatically scales out. And that results into over-provisioning because your business applications are not static. The requirements changes by the day, by the application, and you have to over-provision just to allow for those peak traffic requirements. So AVI addressed these problems head on, and instead of building on a box-like infrastructure, we took a distributed approach where we have built a next generation of application delivery solution with a centralized control plane and a distributed data plane. So the brain of the system is the AVI controller, which is the central point of policy and configuration and management that spins up the micro load balancers. We call them microservice engines, AVI service engines on demand. And the AVI controller provides configurations, policies to these service engines and manages the life cycles. And these service engines are the actual load balancers that provide load balancing, SSL offload, application acceleration services that you expect from the legacy load balancers. In addition to doing the load balancing, the AVI service engines are also collecting a ton of logs and metrics. And then these metrics and logs are then fed up to the AVI controller, which then provides a central dashboard for visibility and analytics into the application traffic. And we'll see that in the demo in next couple of minutes. And you can deploy AVI's service engines in multiple cloud environments. You can have a set of applications running on an on-premises VMware environment. You can have a set of applications running in OpenStack, or some in AWS, or some in even a Mesos container environment. All of this can be managed through a centralized AVI controller, providing a central view of your policies and configuration and a single point of management. So if you were to compare AVI's approach to the legacy approach, instead of taking a network-centric hardware appliance approach, what AVI has done is build the next generation of application delivery, but more importantly, a platform. AVI's solution is a full-featured software ADC that runs on commodity x86, and that allows you to give the low TCO, lower total cost of ownership, and the flexibility that you expect in a next-gen cloud environment. Because of its control plane-based architecture, you have a single point of control, as we saw in the previous slide, across multiple different clouds. REST API is a first-class citizen for AVI, which means the only way to talk to the product is to REST. Our UI, our CLIs, everything is built on top of REST APIs. And that empowers your application developers to do a self-service per application load balancer environment. We provide real-time visibility analytics into your application and your infrastructure that enables rapid troubleshooting and triage, and we'll see some of that in just a minute in the demo. And then finally, because of the horizontally scalable distributed architecture, as your traffic grows, as you add more applications, the load balancer automatically scales itself out. And then when the traffic goes down, it scales itself back in. So you get that AWS-like elasticity and responsiveness that you don't have from your legacy vendors. All right, so with that, we'll go to the live demo. If you have any questions, feel free to ask them on the Q&A panel, and we'll address them at the end of the presentation right after the demo. All right, so let me go to the demo now. So I have logged into the AVI controller through AVI UI. And this is a single dashboard that you see across your entire environment, across multiple clouds. And what I see here is a list of applications. In this case, I have 12 applications or 12 VIPs in the load balancing parlance, what we call them virtual services. These virtual services are color-coded based on the health score. So for example, in this case, this particular application, or this particular virtual service has a performance score of 88, which says the performance, the latency is reasonable, the traffic throughput is doing fine, and on a scale of 100, its performance it's pretty good at 88. But in addition to doing application health, measuring it in terms of its performance, we also measure the risk that might be associated with the application's performance in future. So it's not just a binary up and down about whether my app is up or down. It actually talks about how the resource utilization is on my application. If I'm getting saturated either on my load balancer resources or on my application pool members' resources, we adjust the score appropriately. In this case, we have a resource penalty of 10 or negative 10. Our AVI controller is also a big data analytics engine. So as we saw in the slides, we collect a ton of metrics and logs from the service engines, from the application traffic, and then we correlate that with the rest of the infrastructure. And if we see any anomaly in the behavior, such as a spike in a latency or a drop in throughput, we call out as an anomaly penalty. And a security is an important feature of our product, not just from SSL offload point of view, but also in terms of DDoS mitigation, in terms of calling out any security misconfiguration, certificate expiry, or weak cipher that you might have configured for your SSL. We call that out in form of a security penalty. And we'll address some of these as we go in the next few minutes. But the key takeaway on this is that we give you a much more holistic view on your application's health beyond just whether my app is up or down. Now let me dig deeper into one of these applications, one of these virtual services, and see what's going on. So for a given application, in addition to the health score that we just discussed, we provide a ton of metrics and visibility into what its performance is. So for example, in this case, what I'm showing you is that for these applications, over the last 6 hours, the end-to-end latency from my client to the load balancer, which is in the data center, so this is typically a WAN latency, it's about 100 milliseconds. On an average, the latency between the load balancer and the backend pool members is just about a millisecond and a half, so my local data center network is just doing fine. The application is taking 124, 125 milliseconds to process the request. So this is not a network latency. This is how long the application stack is taking to process the request and start sending out the response. And finally, it's taking just under a millisecond for the data to go back, with the overall RTT as experienced by the end user of 226 milliseconds. Now this dashboard is unique to the industry to what AVI does. There is no agent running anywhere on the servers. There is no monitoring fabric or a span port anywhere. This is an inline analytics solution that gives you the end-to-end latency breakdown. And many of our customers call it a mean time to innocence tool. And you can see why, right? Because today, if there is a problem in an application performance, there is a finger pointing that goes on. Is it a network issue? Is it an application issue or a server issue? And then you don't know where to start. Well, this dashboard gives you the top line starting point to say, first of all, if there is a problem, and if so, where it might be. So in addition to doing this 10,000-foot view of my application performance, I can dig down into the specific individual transactions, right? So for example, we have a log screen in which we collect, the service engines collect logs of the HTTP and TCP transactions and other metrics as the traffic flows through AVI service engines. By default, we propagate only significant logs up to the AVI controller. And the significant logs are the ones that have errors in them, or if we see that there is some kind of abnormal behavior. So you see there are a bunch of 404s that we have highlighted here. If you do want to see all logs and all the transactions, we just click one button, and now AVI controller, the centralized AVI controller, has pulled all the logs from all the service engines, and they're displaying at one location. And you can now run a ton of analytics on top of these logs, as I see on the right-hand side. First of all, let's open up one of the specific log and see what's going on. So for example, this particular transaction, a given transaction, came in from this particular IP address and port, which is a client in US, somebody running a Windows 7 machine with a Firefox browser running SSL TLS version 1.1 with an RSS certificate. So detailed information about your client. It took 19 milliseconds to round trip from that client to the load balancer. So that sounds reasonable. It was handled by this particular VIP and port. It's an SSL VIP, as you can see. And this is the details of the backend connection between the load balancer and the backend pool member. It also has other timestamps information and the length information. It also tells you that it took 1 millisecond on the local network. Is doing fine, no problem. And then finally, the URI that the client was looking for was a particular PNG file. And application was rapid, less than a millisecond, so almost 0 milliseconds to process the request, and data went back in a millisecond with an RTT of 21 milliseconds total. This level of information is hard to find today anywhere in the industry, and this is for every transactions we collect this level of information. Now, you can do, as I said earlier, you can do further analytics and say, well, I see a bunch of 404s. What if I were to know what's going on this, what's generating this 404? Well, I just clicked on one place which says 404 on it, and my Google-like search engine got populated with a query which says, show me only those transactions which have a 404 response code. Now I can go back and see, well, which are the URIs which are generating these 404 errors. And as you can see, other than a few bogus URLs, there are 2 primary PNG files that are missing. And let's say I'm interested in finding out where this particular file is missing, which backend server. All I have to do is, while I have this query on, I click on server IP address, the pool member IP address, and it tells me out of the 2 or 3 pool members that I'm load balancing, I have this file missing on exactly 1 server. So not only I can identify if there is a problem, in this case it's a 404, I can actually root cause it to say that it is because of a specific file on a specific backend pool member, and quickly resolve the problem by copying that file from another server. So this level of analytics, that allows for rapid troubleshooting, is unique to what AVI does. Now, if we can do other analytics, such as we can identify what are the end-to-end latency that the clients are experiencing. I see that a bunch of them which are high latencies. We can figure out these high latencies are coming from a specific browser or a specific device or a specific location. In this case, looks like they're all coming from India. So I can then go back and say what's going on in terms of the end-to-end latency. And I can clearly see that the WAN RTT is pretty high. So I can go back to the data center network team and say, can you look at the WAN connection from our India office? Right? So again, it's a very powerful tool for not just identifying performance problems, but also troubleshooting and root causing them. We also provide a Google Analytics like view in terms of the top geolocations, the top URLs, the devices, browsers, and operating systems. And to bring it back to the earlier discussion, this is what an application developer wants. This is what an application-centric mindset requires, which is, as I deploy my applications, I want my infrastructure to act like applications. I need to give this type of visibility into my environment to know what's going on. And so that's what AVI has done. Now you might be wondering that, well, we have seen nice, pretty analytics capabilities. What about basic load balancing? Are you a full-featured load balancer? How easy or difficult it is to configure and provision? Well, let's dive into that now. Let's say I'm an application developer and I want a self-service solution, which is what our customers do, which is that app developers can fire up a load balancer in 30 seconds or less. So let's take on that challenge. So what I'm going to do is I'm going to say, okay, create a new virtual service. The first question I get asked is, well, where do you want to deploy it? Because we saw earlier in the slides that I can have my service engines running, my load balancers running in on-premises, VMware environment, OpenStack environment, or AWS, all from the same centralized controller. So in this case, I want to pick my default cloud, which is my on-premises VMware environment, right? So I have a single screen configuration for my load balancer. Let's give it a name. I'm going to call it my cloud like LB demo, because that's what we are doing today. That's my name of the virtual service. Now I'm ready to configure the IP address, or if I have DNS configured, which I have in this case, I type in the DNS name and it picks up the IP address from there. That's it. My front-end configuration is done. Well, if I wanted HTTPS, sure, with a single click, I can have HTTPS, and I say, well, I want EC certificate, or I want RSS certificate. I can have multiple also if I wanted. All right, so my front-end configuration is done now. I'm ready to configure my backend. Well, I can configure the backend pool members manually, but if I'm lazy, I can utilize the power of automation that AVI has done. So in this case, my controller is talking to vCenter and is finding out what all VLANs, what all networks are present on my vCenter. I get a drop-down menu of all the VLANs that are in the network. I know my application is running on VLAN 100. I click that, it shows me all the virtual machines that are there, all the VMs. I know my applications is an Apache web server, so I just type a couple of characters and I have a short list of VMs that I want to add. Add servers, save, and my load balancer is ready. That's it. I didn't have to worry about getting an IP address or identifying what's going on or log in somewhere and manually type everything. In 30 seconds, if I were to go in one straight shot, I have a load balancer created. This is the type of experience that the app-centric customers and application developers are looking for, which is self-service, elastic, rapid provisioning. Right? I don't have, naturally, I just created this load balancer. I don't have any traffic running, but you can imagine the type of analytics and logs that we just saw in a couple of minutes ago. Now, one more thing I want to show you before I take questions is the elasticity of it, right? Before I do that, though, let me spend a couple more minutes here, which is what happened here when I just created this load balancer. What happened was AVI controller talked to vCenter, spun up a new VM, or if it had already a VM that was sitting there, which with additional capacity, a load balancer VM or the SCVM, it utilized that, put it in the right network through vCenter, and downloaded the configuration that we just did here on the controller to that service engine. All of this happened in background. All of this saved all the manual configuration steps. Now you can do the same thing, the same level of automation exists, whether you have an OpenStack environment, an AWS environment, a container environment. This level of automation is what is giving you the 30-second experience that you have from Amazon. Right? So I want to take the same kind of automation to the next level for auto scaling. So let me go to another application and let me move it to real time to see what's going on. So in this case, I have another application, another virtual service, and it's running about 360, 370 Mbps of throughput. And it's running with one specific service engine. So one service engine VM is handling the traffic for this load balancer. Now, if I see here, I have a health score that is quite negative. I have a negative 30 resource penalty. And if I want to look into that to see what's going on, you can see here that the AVI service engine is running at a very high capacity. It's running at close to 100%. Now, this is by design for the demo that we have not triggered an auto scale. In a real-life environment, based on the resource utilization of the AVI load balancer, as well as the resource utilization of the backend pool members, we can auto-scale both AVI load balancing itself, as well as the backend application pool members based on predefined thresholds, based on CPU, memory, latency, traffic, etc. In this case, though, for the purpose of the demo, I'm going to do a manual scale out. But look at the power of that scale out. So let me go back to the analytics dashboard. And as I said earlier, we are running about 380, 400 Mbps. What I'm going to do now is click on a button that says scale out. And what this is doing now is it's talking to vCenter, spinning up an additional service engine VM or utilizing an idle sitting service engine VM, putting it in the right network, and scaling out a single VS or a single VIP across two service engines. So with a single click, within seconds, I doubled the load balancer capacity. And as you will see in real time, the traffic will shoot up from 380, 370 Mbps to close to 600 or 700 Mbps. This power of scaling out or doubling the capacity in seconds, either automated fashion or with a single click, is unprecedented. Compare this experience to your legacy appliances where you have to order an appliance, wait for it to come in, plug it to the right network, make sure the configuration is done right, and then finally, weeks, months later, you have additional capacity. And you probably have over-provisioned yourself just to not do that in the future again. With AVI, you can scale out, scale in elastically on demand as the traffic grows, as your number of applications grow. That's the power of AVI. So with that, we have a few more minutes for Q&A. So if you want to see more of this demo, of course, you can reach out to us. Either you can sign up on avinetworks.com/tryavi. But in the meantime, let's take some questions. Grant?
Yes, Ashish, we have the first question here is, how is the AVI controller deployed?
Excellent question. So AVI controller itself is a software. It's deployed as a software, a cluster of VMs or a cluster of containers, depending on the environment. Usually a cluster of 3, 5, or 7, odd number for high availability and performance. So there's an active cluster of, let's say, 3 VMs or three containers if you are in a container-based environment. It's fully highly available. It's all software, no custom appliance.
Got it. That sounds great. We have another question on performance. Is there any performance issues, being that this is a software solution?
Well, that's a great question. But absolutely not. And that's a myth that you need a hardware appliances to scale. There are 2 specific reasons. One, Intel has done a remarkable job in terms of building the faster, better CPUs, x86. Especially with special security instructions for high-performance crypto. So there is no performance issue, even including SSL. And second, because of our distributed data plane architecture, we can horizontally scale out and linearly add performance as you add more service engines. So in fact, for the same performance, we can, when you want to compare us to a legacy solution, for the same performance, we can be 50 to 80% more cost effective just because of the fact that we are running on a commodity hardware and we scale out elastically. So our customers deploy us anywhere from a few tens of gigabits to hundreds of gigabits of solutions, and the solution is scalable up to terabits per second because of its horizontal scale out nature.
Interesting. You mentioned something about pricing. We actually have a question here that is asking, what is the pricing model compared to the traditional hardware appliances that most people buy?
Sure, excellent question. Again, think applications. The legacy appliances are based on throughput, which is, well, as an app developer, I don't know what my application throughput is going to be. It might be small, it might be large on a Black Friday or a Cyber Monday. And instead of doing over provisioning based on the peak performance, our pricing model is based on consumption. So it's a subscription model based on how much you use. And how much you use can be number of applications that you have, or it can be based on how much CPU capacity you want to give us in your x86 environment. So the fundamentally though, it's pay-as-you-go subscription, and you don't have to over-provision. We elastically scale, and then we have true-up licensing if you go beyond what you have. And if you want to know at the bottom line, which is total cost of ownership, we can be anywhere from 50 to 80% more cost-effective than a legacy solution.
Excellent. We have one last question. Anyone else on the line, if you'd like to type a question in, we got one more here. We can answer it. Do we support SSL?
Of course, SSL offloading we support natively on AVI. It runs on service engines, and we can do not just RSA crypto, we can also do elliptic curve cryptography. And for perfect forward secrecy, that's the most efficient way to do that. In fact, with the legacy solutions, you will, if you want to implement PFS, which is, by the way, Apple has mandated that as part of iOS 9 for all their apps, you would be really running at 1/4 or 1/5 of their published numbers because they are not optimized for elliptic curve or for PFS in general. Whereas we can run very high performance SSL, and what you need a very big monolithic appliance for, we can do that with a few cores on an x86 based server. So yes, we do SSL full with PFS, both SSL to the applications as well as SSL to the pool members. We can have multiple certificates, and we can go get into more deeper conversations if you're interested on one-on-one.
Excellent. Thank you, Ashish. That is all the questions for now.
Thank you very much. Thanks, Grant, for the passing on the questions to me, and thank you everyone for joining us. You will find more of these videos and information on our AVI YouTube channel at youtube.com/user/AVI Networks, or you can try out AVI in your environment or in our sandbox, or request for a full demo at our Try AVI link that's right here. So thank you very much again, and have a great rest of the day.